So I'll go ahead and just introduce myself a little bit, and then we'll get started. So my name is Eric Scott, and I work for the Communications and Cyber Technology Department Data Science Group. And we work with researchers in CALS or in ALVSKI is the acronym at large that includes also the vet school and the extensions and experiment stations. And we support research in a variety of ways. And one is doing workshops like this. I've seen a little bit of who you all are in the chat, but if you haven't introduced yourself, go ahead and enter in the chat, just kind of like what department you're coming from. I'd be really curious to know where everybody is coming from. And today we're going to talk about managing complicated research workflows in R with targets. This is going to be a little bit of demonstration, a little bit of hands-on activity as well. So fire up RStudio or whatever your favorite way of doing R code is, because we are going to be doing some coding in R at some point. And throughout this, feel free to just unmute yourself, ask questions, interrupt me. We're not such a huge group that we can't just speak up if you have questions or you want me to repeat something or slow down or whatever. So just let me know if you have any questions or anything like that as we go. Okay, so again, here's the list of packages we're going to be using today. It looks kind of daunting, but actually really the only things that are actually necessary for targets, this package that we're going to be learning today, are these first three: the targets, tarchetypes, and this viz network package. The rest of the stuff is stuff that is going to be used in like a demo project that we're going to look at. So there's going to be a demo sort of data analysis project that uses some of these other packages. And then use this package is going to be really helpful for installing these demos or downloading these demos that we're going to work with together. So the learning objectives for today, the number one thing I hope you come away with is at least understanding sort of what problems the targets package and other sort of workflow managers solve, so that even if you don't go out and start using this workflow immediately, you at least know at what point it would be useful for you, or if you hear one of your colleagues talking about a problem they have in R, and to recommend it to them. By the end of the workshop today, you're going to be able to set up a simple project using targets, view the dependency graph, and run the workflow. And if you don't know what that means, that's okay. We're going to learn what all that means. It's also going to involve learning to write custom R functions. If that's something you haven't done before, written your own R functions, that's okay. We're going to learn a little bit about that today. And then I kind of want you to at least have an awareness of all the stuff that you can do with targets, all the extensions that are available, how you can use it to speed up your code, how you can use cloud computing, something called branching, extensions for Bayesian analyses. Just be aware of those things. And that's kind of how we're structuring this workshop today. And yeah, of course, knowing where to go for help is really important too. And we're going to talk about that a bunch. Okay, so part one, some context. Why would you maybe want to use targets? So moving towards reproducibility is something we talk a lot about in our group. And we say moving towards reproducibility because it's not really like an end goal that you can, it's not an all or nothing. Every little bit of making your analyses more reproducible gives you some benefits. It's going to benefit you in the future when you come back to your analysis in a while, or when you've got revisions from a paper that asks you to make some different figures or something like that. It's going to benefit your collaborators, make it easy for them to see your code and make suggestions, make edits. And it's going to also benefit the entire community. Hopefully, at some point, you will share your code with the world. And if it's nice and reproducible, it'll be easier for people to use and learn from. And what do we mean by reproducibility? If you're not familiar with that term, we're talking about if we're taking the same data, running it through your analysis and getting exactly the same output, no matter whose computer it's running on, where it's running, who's running it, when it's being run. That's kind of like the ultimate goal for reproducibility. And if you've taken one of our workshops before about reproducibility or sort of reproducible practices, you may have gotten the advice that it's a good idea to sort of break your R code up, break your scripts up into steps, and name your files in a way that indicates kind of what order they should be run in. And that is a really great way to help your work be more reproducible. So let's say we've got an analysis that looks kind of like this, right? We've got our data set as a CSV file, and we're not going to edit our raw data. We've got that, read only. And then we've got this script, exploratory data analysis, that reads the data in, maybe makes some plots or something like that. And then we've got a script, wrangle data, that reads in the data, wrangles it, tidies it, cleans it up, changes the column names, whatever needs to be done. We've got a script that fits some models maybe, and one that makes some plots. And then we've got our manuscript maybe written in R Markdown, so even our manuscript is reproducible. So this is awesome. Right here, I've got this clock just indicating that this script has got at least some pieces of code in it that are going to take a while to run. So maybe you've got a model that's going to take hours or maybe even days for that script to finish, right? So let's say you've got this situation and your advisor or your collaborator says, hey, found a few errors in the field data. Can you go ahead and run that analysis again? And you're like, this is great. I've got this reproducible workflow. Totally, I can totally do that, but it might take a while. And so you're thinking to yourself, well, okay, I don't need to run the EDA again. I probably need to run the wrangle data again. I'll just rerun that whole thing. And then in the model script, like, do I need to actually run the really long running one? I'm not sure if the error that got fixed actually affects that one or not. Maybe I can get away with skipping it. For the plots, do I just rerun everything? Might as well. And then, oh yeah, I got to remember to knit the markdown document again. And you know what? You might just decide like, heck with this. This is too complicated. I'll just run everything again in order just to be sure. And whatever, if it takes a few days, no big deal. And so you start that running. And then while it's running, you get another message from your collaborator, advisor, whoever, and they say, hey, sorry about this, but found one more mistake in the data. Can you go ahead and rerun that again? And this is a true story. This happened to me as a postdoc where my advisor was working on cleaning up a data set that was, had entered from pieces of paper that people had collected in the field over a decade and was constantly finding mistakes and errors and saying, oh, hey, can we rerun that? Can we rerun that? So that's scenario one. Another scenario that you might find yourself in is you've got your reproducible workflow, but it starts to get complicated, right? And you've actually got steps that are not necessarily sequential, like 1, 2, 3, but you've got here, for example, wrangle data that can happen independently of a script that pulls weather data from some web API. And you've actually got 4 different kinds of models that you're fitting to the same data. And those can all be kind of independently run. So maybe you start naming them 02A, 02B, and so on. You've got plots for the manuscript, you've got supplemental plots, you've got tables, like those can be run separately in separate scripts. So they don't need to be numbered sequentially. And it starts to get really messy and you start to lose track of the relationships between all of these scripts. And maybe you give up on your numbering system, right? Because you don't know what order to run stuff in. And yeah, it gets complicated. So these are 2 like real world situations that I've experienced, and I bet many of you have as well. And those are 2 of the sorts of problems that workflow management solves. So workflow management is this general sort of concept. In R, we're going to learn the targets package, but there are more general tools, one of which is called Make, that is relatively older. And then if you use Python, there's one called like Snake Make, I think, but they all do kind of the same thing. They automatically, in this case, detect dependencies. So what I mean by that is you don't have to tell it, run this script first, then this script, then this script. It figures that out based on your code. It runs your entire analysis with one master command. So you don't have to be clicking on all those files and clicking, run source. You can just say, run my analysis, and it'll do it all at once. And it'll also skip any steps that don't need to be rerun. And so it'll only run the stuff that has changed. And it's scalable. And what I mean by that is it works for simple projects, complex projects, projects that have big data that is in a database, projects that require you to use cloud computing, projects that need parallel processes running. Like, it's got a lot of options once you learn this kind of framework. And so, here's just an example dependency graph here where we've got steps that have been automatically detected that, like, Bayesian model depends on tidy data step, but that Bayesian model is independent from the random forest step. So I think the best way for me to kind of show you the benefits of this and how it all works is to just do a short demonstration. So to do that, if you want to follow along, you don't have to. You can just watch for this part if you want. But if you want to follow along, this is some R code using the use this package that will install a demo project download a demo project on your computer. And I'm going to do that myself. So if you want to walk through that together, we can. I'm going to paste that code in here. It's going to ask me if it's cool to put it on my desktop. I'm going to say yes. And then it's going to ask me if it's cool to delete the zip file. And I'm going to say yes. And that will open up a new R session. Oops, over on my other monitor here. And should look kind of like this. And there's some reactions on Zoom that we can make use of. So if you want to give me like a little the green check mark, if you're good for me to move on, either because you've figured this out or because you just want to watch. And if there's any issues, do a red check mark. Cool. See a bunch of green check marks. So let's see here. Do you guys see in your version of this, are you also seeing this underscore targets folder? I feel like that shouldn't be there.
I don't see that.
Okay,
I only have a data folder and an R folder.
Let me do this again just so it matches. I think because I already had it on my desktop from a previous try that it did that. So let me try that again. And Jessica says no. You having issues?
Just take some time. Got to move it to the right spot.
Oh, okay. All right.
How did everyone get green arrows so fast?
Well, they might have just wanted to watch at this part. But we are going to do this again later to do some actual hands-on work with a different demo project. Okay, so this is kind of what your folder should look like. And so in the data folder, there's this penguins underscore raw CSV. So this is like an example analysis project, a very simple one. And in the R folder, there are two R scripts. And this is going to look a little different than your typical analysis project, probably, because in this, there are functions. And we're going to talk about why that is in a second, or we'll see why. And there's also this bit here. So we can see that we need the tidyverse, we need this janitor package file, and then this get data function takes the file and reads it in and does a bunch of data wrangling stuff, right? So if I run that and I do get data file, right? I've got the file as just the path to that file. It will read it in and do some wrangling. And I could save this as data. And then in this fit model script, this has functions, again, a little bit different than you would probably normally write, but it takes that data and it fits some linear models with the data. One that's got flipper length as a function of body mass, sex, and the interaction between body mass and sex, and then one that doesn't have the interaction. And so we can run those functions, or we can load those functions by running those lines, and then we can do fit lm full data, right? And it gives us a linear model. We could save that, as M1 and, do summary M1, right? So this is our R code without the targets package. So I'm gonna just delete some things here, comment some things out to put it back the way it was. And I'll show you now what it's like using the targets package. So start by loading targets. And then targets has a use_targets function that does some of the setup. And so you see down here, it's creating 3 files, this _targets.r, run.r, and run.sh. And it tells us to modify _targets.r. So we'll start there, and then I'll come back to talking about what these other files are. All we need to do is go through and follow the comments below to fill in the script. So it's starting with loading packages that are required to define the pipeline, in this case, only the targets package. Then here we're setting some target options, including what packages are needed to run the actual code. And so in this case, it was the tidyverse package and the janitor package. So I'm going to go ahead and load those in there. Then we've got some options for parallel computing, which it tells us are okay to leave alone. So I'm going to ignore both of those. And then we've got this tar source that runs.
Can you slow down a bit, Eric? I'm having trouble following.
Sure. Yeah, I can slow down. At this point, we don't actually need to do much in here, but yeah, I will slow down.
Well, there wasn't a target. Sorry, you created this _targets.r, right?
Mm-hmm. It was automatically generated by the use targets function.
Right. I had to install targets first, so I had
a
step behind, and now I'm at the packages. I need to go in there and change it to tidyverse.
Yep, tidyverse and janitor.
Okay.
We don't need to do anything with these lines. These are here. It says okay to leave alone, and we'll talk about what those do later on. And so I'm just explaining kind of what the code does as we go along here, but this is all like automatically generated for us, and there's not much here that we have to edit. We're not to that part yet. Tar source is a function that is going to load all the R scripts in the R folder, so those functions that we have in there.
Well, I guess one thing that's stopping me a bit is when I did the use targets, I got something that you didn't get, which is a red X and says install packages future.callr and future.batch tools to allow the tar make future options. And so then this _targets.r looks a little different from yours. I don't know if that matters. Thank
you for bringing that up. Yeah, that's totally fine. If you didn't install those future.caller packages, that's totally fine. It's not a problem. That's this parallel computing stuff. So that might look a little bit different for you, and that's okay.
Okay, but it's not relevant to this example.
Nope, not relevant for this example. Yeah. And then down here inside of this list is where we're going to define our actual workflow. And so it tells us here to replace this list with your own. So I'm going to go ahead and delete everything that's in there. And I'm going to define some targets. And if this doesn't totally make sense what's happening right away, that's okay. We're going to go through what all this means in more detail in the slides. I just want to kind of demonstrate how this all works. So we define targets with this target package. A target is basically a step in your analysis. And so the first one is going to be our file, and that is going to be literally just the path to the file. This is a kind of a typical way that a targets project starts off. And I'm going to tell it format equals file. This is something, I'll talk about why you do that later. And then we're going to read our data in. And so I'm going to call this target data. And then the code that we use, oops, not data, is get data. And that is going to take this file target. And then we've got our two models here, fit_lm full and fit_lm no_int. Those are our two functions that we've written. And so I'm going to call this lm full.
So you didn't need, in the second tar target, you didn't need to specify the format?
That's right. Our default format is set up here in this tar option set. And you'll see what that means in a second here once we actually run it. No int data. Okay, so we've got all our functions that are written in these files here now are represented in this list here as targets. So I'm going to save that, and then I'm going to run tar visNetwork to visualize our dependency graph. If you haven't installed the visNetwork package, the first time you run this, it'll prompt you to do that, by the way. So this is how all those steps are related. Steps and functions are related. So the functions are triangles, and the steps that are called targets are circles. And it has figured out how they're all related. This is not coming from the order that these are. In fact, I could put the model, I could put one of these models up at the top of the list, for example, save it and run tar visNetwork again, and I would get exactly the same answer. So it's figuring out the relationship between all these steps based on the code that you've written. And
hey, Eric, I'm getting an error with that. I don't know why.
With tar visNetwork?
Yeah.
Me too.
So did you say it's a separate package that doesn't come with targets or something?
There's a package called visNetwork, and I think it'll prompt you to install that if you have it.
It did not, in fact, prompt me to install that.
Oh,
yeah.
Okay.
So it's just
you might need to install visNetwork. It's VIS capital network.
Well, I don't know because I just said library visNetwork and it says that I have it.
What is your error? Because I got an error too.
Let's see. It says, well, warning, package targets built under R 4.1.3, error, target errors, tar meta fields equal error complete only equals true. I mean, I don't know what any of this.
So it sounds like it's an error in the actual targets pipeline. Make sure that you've saved this file before you run it. And we're going to do some debugging later on. So for now, we can just take a look maybe and just watch what happens. And we'll come back to that. Is that cool?
Are we going to come back to it on this example? Or are we going to move on from this example?
We can come back to it on this example. Yeah, we can.
Okay.
So if I want to run it, I can run tar_make, and that will run all these targets. So it's starting the target that we called file first, building it, starting a target called data, building it, and building all our targets. And now if we run tar visNetwork, now if I run this, I'll see that these are all green. They're all up to date. What happens if I change something? So let's say I change something about the data here, the data wrangling. For example, like let's just comment this line out. Let's not make sex lowercase. And I'll save that, and I'll run tar visNetwork again, and it will automatically detect that step is out of date. And because that step is out of date, or because that function is out of date, the step that requires that function is out of date, and everything downstream from it is also out of date. So next time I run tar make, it's going to skip this target, and it's only going to run the ones that are outdated. And so we should see that here. Yep, skipping the target file, but it's running the other targets. So if I run tar make again right now, it's going to skip them all, and it's going to be really fast. We could see another example where maybe I just change one of these functions like, I don't know, let's just add another variable in our data, which we still have here loaded from before. Let's add, I don't know, bill length, bill depth to our model, just for the sake of testing something. And so now we see only this one is outdated, or only this function is outdated. So only this target is outdated. So when I run tar make again, it is going to skip everything except for this lm no int. So what I'm hoping you can see at this point is the benefits of it, and I'm hoping you can look past the stumbling blocks we've encountered into getting it to work, because we're going to work through all that stuff. So this is super useful for those two situations that I described at the beginning. It keeps track of all the relationships automatically, somewhat automatically. You still have to think about it a little bit in terms of how you sort of chunk things. And it's going to take care of only running the stuff that needs to get rerun automatically. Now, how does it do this? What's happening in the background? Well, if we look back at our files tab, it is created, since I run tar make, it's created this folder called _targets. And this is nothing we never need to touch this manually. But if we look in it, we can see that it stores some metadata about the pipeline, about the status of the pipeline, and it stores some objects here. And these are those targets that we created. This is our data. This is lm full, and this is lm no int. And these are being stored as RDS files because we told it to do that up here as the default. An RDS file, if you're not familiar with, is something you can use in R with just like the save RDS function. It's just you can save any R object out as a file using that. And so that's what it's using in the background. And in fact, we could read RDS _targets / objects / lm full. We could do that and get it in if we wanted to, but that's not actually the way you're like supposed to do that, because there's this nice shortcut tar _read lm full. And if we wanted to instead just load it into our environment, we can use tar _load lm full. And now it's here, lm full. I can do ANOVA lm full, right? And so on. And so this is part of kind of the workflow of building a targets pipeline workflow, whatever you want to call it, is running it, loading a target, doing some work on it, turning that work you're doing into a function so that you can write the next target and iteratively build it. So, yeah, Jeremy, you have a question?
Yeah, just to confirm, on the _targets.r file that you have open on the screen right now.
Yeah.
For the tar source function.
Yes.
You didn't have to enter in any of the .r files that you had written. So its default behavior here is that it's going to read whatever is already in the R folder, correct? And that's why you didn't have to list them?
Yeah, so basically what it's doing is it's running source on all the files that are in the R folder. So if you had a different folder, if you called your folder something different for some reason, you wanted it to be something non-standard, or you had functions that were somewhere else that you needed to source, you could just do that yourself. You could just write some R code here to source those in. So this tar _source function is relatively new. And before that, people would do something like lapply, list.files are something or other source, something like that, that would like iteratively apply the source function to all the files in this R folder. So tar source is just like a shortcut for that. In fact, we can look and see what it says. Yeah, it just runs all the R scripts in a directory. And so you could actually just say, if you didn't want to call your folder R, you could call it whatever you want. You could say files equals my scripts or my functions, whatever you want to call that folder. Yeah,
Terrific.
Jessica.
Thanks.
Great question. Follow up to that, which is, and I'm sure you're going to cover it, but this requires that your code that may have been analysis code to be written as a function and put in the R. So, which is fine. But when you started using this, did you like start a project from scratch straight away in this format? Or do you like have a process of just kind of linearly thinking, type, I got to do this, I got to do that, and then like converting it over to these functions later to be used with the targets package?
That's usually, so that's what we're going to do. We're going to have an exercise later on where we take an already existing analysis project that is much more like what you're used to, that doesn't have these custom functions, and we're going to turn it into a targets pipeline. And I think that'll provide a really good, kind of demonstration of like the thought process that you would go through. So, but you bring up a really good point, and that targets, using the targets package is a pretty different way of writing R code, of doing analysis than a lot of people are used to. And so there is a little bit of that, like, you know, activation energy. And part of what we'll talk about today is like thinking a little bit about when you want to use targets. And it does depend a lot on your familiarity with using it. And so when I first started using the targets package, it was worth it for me only when the benefits were like super clear. So when I had a lot of steps that were running in parallel, or that could be running in parallel and were taking a super long time, or when I needed to use the HPC to run stuff, like then it was like, okay, I need to use targets. But now that I'm more familiar with it, I'm much more likely to just start a project using targets, because even for pretty simple projects, I feel like it pays off. So it depends on how
I've done this
familiar
method
you are.
before, right? Like turning things into functions, parallelizing it locally, but like I just got to a pain point where that was needed, and then I did it, but I didn't like go back and change the whole repo's worth of munging scripts, whatever scripts into the same format. Along those same lines, so some of the functions I have written to do this, I have the library, or I have like the require packages inside the function itself. Does it matter whether you have it appear in your underscore targets and put every single package you ever need under that tar option set versus like putting it in each function as you go?
It's so you can, there are multiple ways to do this, as there are with most things are. So the benefit of putting the packages in here is that it's only going to load the packages that are needed for particular targets. And in fact, you could even supply the packages argument to a specific target. Like you could, if you had some really big package or something, like you're like, I don't need to load this for all of these targets. It's only needed for this one, function. You can go packages.
But it's the equivalent of like when you write the function itself, putting inside the function require.
Yeah. So the difference is when you run tar-viz network, it basically goes, it runs this file. And so if you have a bunch of calls to library here, if you have library tidyverse, library lubridate, etc., or you have them in the functions that are getting sourced by tar source,
in the get data function.
Then every time you run tar-viz network, it's going to load the tidyverse, load lubridate, etc., etc., etc.
Visualize it.
So it just kind of slows things down. And so if you put them in here, it's only gonna load those packages when it's actually running the target.
When you're running it, not to make it. Okay, that's a somewhat minor difference. But I was just used to, if I'm writing the functions and I like to require the packages in the functions, it seems natural to put it there. But okay, that makes sense.
And you'll see like when we look at, I'll show some links at the end to like targets projects in the wild, and you'll see different ways of doing it. So in the interest of time, I would like to move on. Would you
mind copying and pasting your tar targets list into the chat?
Oh, sure. Yeah.
I am
can
getting
do
an
that.
error, and I think I might have a
One of the
mistake
most
here, so-
common errors is if you have a comma here at the end. It
Ah,
won't work.
yeah, I could see that.
But I'll go ahead and copy and paste this list into the chat.
Thank you.
And then we're going to have plenty of time to do some debugging with a different project too. So yeah. Okay. Okay, so again, I want to move on just in the interest of time, but do still, interrupt if you have questions about things. I'm happy to answer them. I think I talked about this. So we saw this. We call these targets, these circles are targets, right? Everything, all these intermediate steps are stored as R objects in that underscore targets folder. That's sort of happening behind the scenes. And everything that happens to make a target is written as a function, which is a very different way of kind of doing an analysis project in R, but I think has a lot of benefits. Oh, one other thing is I did say I would tell you what those, what these are, run.r and run.sh. These are just little helpers. Like this is just a script that has tar make in it. So if you wanted to run this as like a background process, you could. In R, you can do like source as background job. And then you can still use R while that's running. And then in the background, it's running your targets pipeline. So that's just a little helper there. And then the run.sh is like a shell script to do the same kind of thing, which I never use because I don't know how to use it. But you can read more on in the targets manual about how to use that if you want to. Okay. So yeah, part 3, we're going to look at a different project and we're going to get some hands-on experience doing some refactoring. So if you haven't heard refactoring before, refactoring is the idea of restructuring code without altering the functionality. And so we're not going to be asking you to change the way this analysis workflow works. We're just going to turn it into a targets project, hopefully. And this is another thing that you can download to get started. And so I want everybody to this time do this. If you didn't last time because you just wanted to watch, that was okay. But this time I do want you to download this. So run this code, follow the prompts, and take a moment on your own to just look around, look at that project, run the code in it, maybe try to figure out what the steps are doing, what the analysis does and all that. And we'll take maybe about like 3 minutes to do that. I'm going to go ahead and install this as well. So we're going to go through like step by step how to refactor this project to use targets. So the first thing, like we saw in my demo earlier, is to run that use underscore targets function, and that will set up the infrastructure. The second thing is to add package dependencies to that tar option set, that packages argument, figure out what packages are needed. Third step, converting R steps to functions, writing targets, running tar.make. Those 3 are usually best done kind of iteratively, not all at once, right? You don't want to turn all the R code into a function, write all the targets, and then run tar.make and get a bunch of errors. You want to do it kind of one step at a time, right? Start with the data, read it in, write a function to do that, write a target to do that, run tar.make, see if it works, and then move on. And of course, there's going to be debugging involved. So we're going to walk through this process together, and I'm going to kind of cue you for what step we're doing and how we're doing it and how long we're taking, everything like that. So the first step is to just run use underscore targets. So everybody can do that right now. If something goes wrong, you can let me know and we can figure out how to fix it. So that should generate that _targets.r file and open it up for you to edit. And it should generate that run.sh and run.r script, which we don't have to worry about. So that was step one. We did step one already. Nice job. Step two is figuring out what are the packages that are needed and adding them to this packages argument in the tar options set function in the targets.r file. Sorry, there's a lot to say there. Yeah, so you're gonna look in targets.r, look for this tar option set, figure out what packages this project needs, and put them in there. And so take a couple minutes and do that right now. Just do that individually. So your packages section, well, let me get caught up here. Use _targets. Oops, I'm going to load it first. Use targets. So in here, we should have tidyverse, janitor, car, and room. Okay. All right. Next step is to create functions. And we're going to go through, I'm going to talk about like a few steps here, and then we're going to work on it in groups. So if you haven't written a function in R yet, that's totally fine. We're going to go through that right now. So functions in R are created with the function, which is fun to say. And this is the kind of the structure of an R function. So we start by giving it a name and using this assignment arrow. And so here in this super simple example, I'm making a function called add 10. And we assign to it the function with in parentheses, this is where we define whatever arguments we want that function to have. So in this case, just X. And then open it up with curly braces. And then inside of the curly braces, it's what the function does. So whatever R code you want to type in there, starting with these arguments. So X plus 10 is all this function does. And then it ends with a curly brace closing it. And then we can use that function after we run those lines in R to like source it. We can use the function here, adding 10 to 13 and getting 23. We can also write functions that take multiple arguments, and I think this is going to be useful for this refactoring exercise. So here's an example where we've got a function that takes weather data and field data. And inside of this is basically like if we just ignore everything outside of these curly braces, we've just got some regular like data wrangling code, right? We're taking field data, we're doing a mutate on it to change the format of the date column, saving that as field _data _clean. And then we're doing this left join to connect it up to the weather data by the date column. And all we're doing here is just like wrapping that in curly braces, figuring out what the starting points are. So we need weather data and field data clean to do this step, but field data clean is actually created here from field data. So we need weather data and field data to do this. And then we're calling this whole thing something. We're calling it join _data in this case. So we can we don't have to edit the data wrangling code in here. We just have to kind of wrap it up inside of a function. Did somebody have a question?
Yeah, so usually if I was to write this type of code, I would have that left join statement create a new data frame, and then the function would return that data frame.
Good point. Yeah, wherever the function ends, it has to return something. So I can't, if I ended this instead by assigning this left join to something called data frame complete, this function is not going to work because it won't output anything. So we have to end it in outputting something. And so like if we did assign it to something, like if we did assign this left join, if it ended with being assigned to data frame new, well, we could just add another line that calls data frame new and spits that out. And then that function will work.
With the targets package, Eric, are we still expressly writing things to particular folders? Or because the targets, when it runs, it saves those RDS files anyway, is it redundant
Yes.
now to expressly say, I want this to be put in the data cleaned folder?
Good point. Yes, there are some steps in that analysis that I think write files, and we don't necessarily need those anymore. Now you can include those if you do want a targets pipeline that is going to output files, like if it's going to save some plots or something, you can write targets that save files, and you need that format equals file argument with them. But yeah, if it's just like saving an intermediate, well, we don't need to do that anymore because targets is going to take care of that for us.
I feel like this potentially could not challenge, but be a different way of organizing folders that I feel like with the research compendium and everything, like we have the raw data folder and then we have the clean data folder, which is so
That's right.
I'm not thinking about that so much because it is there. It's in the targets.
It's there, yeah.
Folder, but it's just not, I don't need to think about where it is or name it or keep track of it.
That's right. Yeah, that's
Okay.
right. Yeah, you don't necessarily need to save all those intermediate outputs because targets is doing that for you and keeping track of them for you.
And even if you were to start with those intermediate files, you still don't need to know where they are as long as like targets
if they
will
are
figure it out
targets
for me.
Yeah, if they are targets, if they exist as targets that you've defined, and you have a target that's called data clean, and you want to do something with that, all you have to do is write a function and another target that starts with data clean.
Starts there, and it just has to have the same name, and so the targets can't have the same names.
The targets have to be uniquely named, yes,
because they're all going in one big folder, so you can't just distinguish
they all have
them
to be
by
uniquely named so that it can keep track of how they're all related to each other, right? They have to have unique names. Yeah.
Interesting. Okay, thank you.
Yep. The functions that we write do not have to be amazing. They don't have to be great. They just have to be good enough, right? We're not writing functions to make an R package. We're not writing functions that are going to be reused anywhere other than this specific project. So they don't have to be reusable. All we have to do is kind of wrap them in that function call, wrap the code that's there. But we do want to use some like best practices. So it's a good idea to use some kind of naming convention. So for example, like all your target or all your functions that create plots, maybe you should start with the word plot. All your functions that fit a model should maybe start with the word fit or something like that. Whatever your convention is, doesn't matter what you pick, but just pick something and be consistent. I think verbs are a good idea for functions. Make the function arguments the same as target names, I think is a good idea. And that helps you keep track of like what that function is supposed to do. And document what your function does, leave comments. So here's an example, like kind of a bad version where we've got a function that's just going to be called M1 and it takes an argument X and, it fits a linear model. This function does the exact same thing, but it's called fit model. The argument is called data underscore clean, which is what the target is named, I guess. And it also has like some comments about what it does. Oh, with a typo in it. Step 4 then is creating the actual targets. And so targets are defined by the tar target function inside of that list at the end of the targets.r. Usually tar target only needs the first 2 arguments, which are name for the name of the target and the command argument for what it does. Targets that are files or save files also need this additional argument format equals file. And what that does is it actually tracks the file contents on the disk. And so you would use this in this case for this penguins raw.csv, so that if I edited that, which I shouldn't do because I shouldn't manually edit my raw data, but if I did, then it would detect that and it would invalidate that target and everything downstream of it, and it would know to rerun that. If you're loading a file from the web, you use format equals URL. And then this common error that I mentioned before is if you leave a trailing comma, because list doesn't like a trailing comma. If you leave a trailing comma, you'll get an error. Error running targets tar make last error argument, something is empty. That means you have a comma issues. Not a super informative error, but.
So sorry, when you said not to change the raw data, I mean, I understand that's the best practice, but also in the example that you use, the motivating case where the advisor has an updated data, that would be the case.
That would be the case. Yeah. So somebody sends you some updated data, you drop it in, the same file name or whatever, Targets automatically detects that there's a change that's been made and automatically, reruns any targets that depend on that data file. Yeah.
Thanks.
Naming targets is also a challenge, and thinking about like how many targets there should be. But again, use some sort of naming convention. I think nouns are good for targets, make them concise and descriptive. So, bad would be like data 1, data 2, data 3. Better would be data underscore file, data underscore raw, data underscore clean. Histogram by site plot is a little bit too verbose. So you might call it like plot hist site or something like that. So now what I'm going to do is we've dwindled a little bit, but with the people that are here, we're going to pair up and work on doing this refactoring as a pair programming exercise. And so if you've never done this before, basically the idea is one person is going to kind of share their screen and be the driver, and the other person is going to be the navigator and sort of talk through what we should do next, what the next steps should be, how to write the targets, what we should call it, what piece of code should get turned into a function, et cetera, et cetera. And so, yeah, I'm going to go ahead and see if I can figure out how to assign breakout rooms. Jeremy here has a good opportunity for us to talk about debugging targets. So I thought we would just do this together. So Jeremy's got a target pipeline here where we've got a target called Maples raw. That is the path to the file, the CSV file. And then we've got a target called Maples, and that calls a function that he's called read wrangle data. And we're getting an error. And the error says, last error, no clean names method exists for the character class, consider janitor, right? So it's not super informative. So like, what are we going to do? How are we going to debug this? Well, we know that the error is in the target Maples. So we're going to go over to the read wrangle data function. And we're going to go ahead and click on that tab. And in the console, we're going to run a couple commands to kind of like set things up. So one is going to be tar underscore, what is it? Tar load globals. Tar load globals. So this is going to look at that targets.r file, and it's going to do everything like load all the packages that you need, source all the functions that you need. It's going to get that all set up, but not actually run the targets pipeline. The next thing you're going to do is you're going to load that Maples raw target. And so you'll run tar underscore load, parentheses, Maples underscore raw. So now that's available in your environment, right? You see it in the environment tab, it's there. So now what we can do is we can try running our function, the read wrangle data, and we can see that error now, like without the extra layer of targets on top of it. So we can run that on Maples raw, and we can see the problem. Now we could like click on the show traceback, or whatever. We can also just go through your code up there line by line. So you can go to like line 4, starting with Maples raw, and you can run it and you can see what happens, right? And figure out what's going on here. And we could just run like, if we just highlight from, just from there to there. Okay, so now we know where the problem is. What is Maples underscore raw? That is just our character path, right? So I don't know, do we see what's missing here?
It hasn't been read in yet.
Yes. So I
Right.
think your
It's just the
function's
path
missing
filing
the
or
read
file
CSV
pathing.
step. Yep. So that's kind of like the process. So if you go back to that that read wrangle data and you add in a so the first thing should be read CSV Maples raw.
There we are. So that would be in here.
Yeah, so that was missing.
That's my fault. I told Jeremy, I thought that like some magic was going to happen to create
To
this
read it in,
object.
yeah. So
It sounded good to me too,
but what
David.
is it
I'm
reading
just-
in this case?
I believed you.
It's reading in it's not reading in that exact file. It's reading in
Maples raw.
Maples
the
raw,
target.
because Maples raw
Okay.
is that path, right? So in
I
your
was under
your
the-
function,
Yeah, I was under the impression that this first tar_target bit would have already read it in, and it would
yeah,
be sitting there in the targets objects section of our.
got
project.
it. Yeah. No, so that format equals file is just telling it, no, this is literally a file. It's literally a file on disk called HBR Maples raw CSV.
Okay.
And so
And it
if
just.
you,
Oh, go ahead.
yeah, go over to that. Let's fix it. Let's make it work. So go over to that function read wrangle data again, that tab. So we're gonna read in not the literal path to data.hbr Maples. We're gonna read in Maples _ raw, because that's the target that contains that information, or it's an argument to your function. And so now if you save that and run tar_make, it should work. Cross our fingers. Yep. Cool. And so now you could do tar read Maples, and it should show you a data set. Just Maples, right? Yeah. There we go. Cool. Awesome. Thanks. Thanks for the demo.
Yeah, thank you.
All right.
Sorry. So as soon as I replaced the path to the CSV file with Maples raw, I got an error. When I have the read CSV, I don't know, maybe I can show mine.
Sure.
I just don't know what I did differently than Jeremy.
Yeah, you can share your screen if you want.
Okay. Did that share? Okay, there we go. So when if I do this, then I've got
so you
tar
want
make
to so this is okay. So this is let's do something a little bit different about this function to make it more clear what's going on. Instead of calling the argument Maples raw, let's call it file.
Okay.
Or file path or something like
Maples
that.
file.
Sure, Maples file. So your first step, read CSV, should be reading in Maples file, not an actual hard-coded path to make it like a function.
Okay, so that first target is literally the path itself.
The first target is
not the actual content of said path. It is just the path.
It's just
name.
It's just saying this is where the file exists. Yeah.
And can I ask a question about naming? I feel like, yeah, it can get really confusing really quickly if you don't stick to like a consistent naming scheme.
Yeah.
When we have if the function is called read wrangle data, does that mean the name of our file should also be read wrangle data in an R folder? Does it have to be that way?
It doesn't have to be. No.
It can find it.
I like to do that
regardless.
because it's easier to find. But it could just be, you could have all your functions in one file just called functions.r.
Oh,
that's
so
totally fine.
Targets is actually looking inside the file at the actual functions themselves, not just looking at the name of the file.
It's doing the equivalent of clicking that source button in the corner, you know, for all the files that are in the
and
R
it could
folder.
be, and you could have an R script that has multiple interrelated functions, for example, all in the same one. Okay, I've been separating them all out.
Totally. I separate them out because it's easier to find, but yeah.
Okay.
Okay.
I can stop sharing now?
Yeah, that would be great. And I do want to, even though everyone's gone, I will show the last little bit of this. Well, we just saw debugging. And I went through that. Another thing that you can do is if there's a problem in the actual targets pipeline, there's a function tar, or actually this is, sorry, tar meta lets you see the error messages for individual targets a little bit easier. And this is the steps that we just walked through with Jeremy, how to kind of debug things. So I won't go through that. Okay, so I do want to mention this tarchetypes package. In your _targets.r file, there is a line that is by default commented out. But if you uncomment that to load the tarchetypes package, it gives you some nice little like helper functions and shortcuts. So you can, with the tarchetypes package, instead of using list to hold all your targets, you can use a function called tar_plan. It's an alternative to list that has a couple benefits. One of them is that the trailing comma is okay. Just a little minor quality of life thing. Another one is that it gives you an alternative way of writing targets where you can write the name of the target equals the code that the target runs. So this is a little bit more concise way to write it. And I really debated about how to teach this course, whether to teach it right off the bat with this, this way of writing targets or using that tar_target function. I like this better, but it doesn't work in all situations because you can't provide it any optional arguments, right? So the tar_target function has a bunch of other arguments that you might need to set for special situations that you can't set using this format. It also provides a bunch of shortcuts like tar_file. This is a very simple shortcut that basically is tar_target with format equals file just set for you. But it's like maybe a little bit easier to remember than remembering format equals file. And it also provides functions so that you can include rendering our markdown documents in your workflow on your targets pipeline. So there's tar render and there's a tar quarto. And yeah, that trailing comma is okay. So now that we've gotten a little bit of a taste of what it takes to turn a project into a targets pipeline, and you've seen that it is possible and that you can do it, I want to just give you a little bit of a taste of kind of what's possible and some of the powerful uses of targets that might be a reason to get over the activation energy of doing this. Yeah, Jessica.
Sorry, before I was trying to do like writing out and I got an error. So I was hoping to.
Oh, how to save a file?
Yeah, and I don't know if my error is because of something else or because I was trying to save a file. So
yeah, you should be able to use the for example, tar file or a tar target with format equals file. The trick is that your function has to return the path that it's saving the file to. So, and a lot of save functions do that by default. So like
save RDS would do this easier than because I'm currently using
if you want to like, yeah. So if you wanted to like, for example, have a target, like we can make one right now.
Or I have it pulled up right now on my computer if you want to like look at it.
Sure, we can do that.
Awesome. Share screen. So there was a part of this exploratory data analysis at the bottom that was like summary statistics, like, oh, maybe you'll want to save that for later use or something. Like I can imagine wanting to keep some intermediate files I want to keep around so that I can find them again and do whatever to them. Okay, so I saved it as maple summary. I'm starting from my data clean, which up until then had worked. But now I'm having, and now I want to save it out to this particular location. Or use write_CSV. And in my targets, I'm going to call this target sum data. It's my summarized data function with data clean, and my format is equal file. What am I missing? Or help me understand this error message, I guess. I don't know. It could be anything.
So the target did not return a character. So the file format equals file, the function has to return some kind of path. So if you go back to your function,
okay,
And
because it
all you-
worked, right? Because Maple Summary
yeah,
actually lives here now. So I was like,
Yes.
wait, so how is it still an error then?
right. But targets doesn't know where it is. And so what you just have to add at the end of that function is
Mhm.
just I guess just the path in this case. So if you just copy what's in quotation marks and put it on the next line,
Like,
then when you
like
run
just
that
literally
function,
like the next line
yeah.
of the function?
yeah. So in practice,
Oh.
like you might actually, what you would maybe want to do instead is have like out path as an argument to your function or something like that. And then at the end of your function, it returns the out path. But this will work, I believe. So now when you run this function, the thing that it will actually return is the path to the data that's being saved. And
So
targets
now-
will know where that
Ah.
file is now.
So if I did tard viz network, it says that there's an error, right? It errored there
Mhm.
last time.
Yeah.
But if I do make now, there are warnings, but not errors. And if I do the tard viz,
And now it
Well, weekly.
now it knows where it is. Yeah.
interesting. The function
So-
has to, okay, has
So
to
with
have,
format equals file, the function has to return a file path.
and the last one I made to ggplot with ggsave, I don't know, I didn't do that for this one.
ggsave returns the file path
It already
when
does.
you run it. Like that's just a ggsave thing. So yeah.
Oh,
Yeah, and a lot of save functions do, but apparently, right, CSV doesn't. I
interesting.
thought it did, but
But if I did
guess
like
not.
save RDS, it would or something?
I don't know. It depends
Yeah,
on the
or it
individual
could.
function. Yeah.
Okay,
I don't know.
interesting. Okay, sorry. Sorry, I just wanted to
No,
like
that's
know
right.
about, I was like, I did the format equals file thing. Why is it still erroring?
Yeah, yeah. So
Thank you.
Yep. Okay. So taste of what's possible. So there's a bunch of extensions. There's the Targetopia is what they call their version of sort of like the tidyverse, right, for targets. Targetopia includes these two packages, stand targets and jags targets, that provide what are called targets factories for Bayesian analyses. So you can define one thing in your targets.r, like tar, stan, mcmc, for example. But then when you look at the tar viz network, when you actually run the pipeline, it's actually doing a bunch of things. It's generating targets automatically at runtime, like when you run the pipeline, that do stuff like wrangle data, run the MCMC, create a table of posterior draws, and other stuff. So these exist if you want to do Bayesian analyses with targets. And one of the in the wild projects that I have at the end uses, I think, stand targets. Parallel computation, in my opinion, is one of the most powerful uses of targets. So in this workflow, for example, Bayesian model, random forest, deep neural net, all of these like are not dependent on each other. And we could technically be running them all at the same time on multiple cores of your computer, or as multiple jobs on an HPC. And targets makes this pretty darn easy. There are two functions in targets to run things in parallel. There's tar make future and there's tar make cluster make. They both take an argument workers. So you can say workers equals 5 to run 5 targets at once. And I can just, I can demonstrate that real quick, maybe, if I find the right RStudio window. We can just make some dummy targets that do something like, we're just gonna do something that takes 5 seconds, right? So this is obviously not real. It takes 5 seconds too. And we'll do a third one. So these are not dependent on each other at all. So this is kind of a silly like toy example, but if we run tar make, it should take like about 15 seconds for the pipeline to run. And got an error because I did a typo in these two. That's hilarious. Let's try that one more time. So this should take about 15 seconds. And if we do these in parallel, since they're not dependent on each other, these can all run at the same time, should take about 5 seconds. So here we go. It took 11.4 seconds, or wait.
That's
weird.
because it skipped because you had already.
Oh, it skipped one. Yeah.
Yeah.
So I need to remove these. There's a shortcut for that. Tar destroy removes the entire underscore targets folder to like start over from scratch. And we'll do tar make cluster MQ this time, workers equals 3. And so now it should take like 5 seconds. Oh no, I don't have this installed. Do I want to do this right now? Sure. Oh, there it goes. That was quick. So it installed them, and it's not going to take exactly 5 seconds. It took 7 seconds here. And that's because there is some overhead for setting up the parallel workers, right? And then tar make future workers equals 3. Oh, it's going to skip them all. Anyways, that does the same thing. There are differences between the two backends, cluster MQ and future, that are discussed in more detail in the manual. Cluster MQ involves installing like an additional command line utility called 0MQ, whereas tar make future doesn't. Cluster MQ, I think, is usually the better choice because it uses what it calls persistent workers. So it only starts up those 3 workers once, and then it passes targets to them as it goes through the pipeline. Whereas tar make future makes what are called transient workers. So it creates a new worker for every target it's running, which is more overhead.
You know, I actually really like that, the Bayesian example in that. I feel like I've discussed this with David and folks in the past who are like, well, I don't, the standard kind of research compendium approach where there's like a model and a thing is like, well, when I'm doing Bayesian modeling, I'm trying like 5, 6, 10, 12 models. And I don't always know which one I want. And so I feel like, I mean, I still have to come up with names for them and name them targets,
Sure.
but like they're in parallel. They're not like consecutive models, like the, you know, model B depends on model A. It's just like I tried 15 hypotheses of what I think the best model should fit, and this will let you run it in parallel, and also just not even in parallel, just keep track of it in a way that
Yeah,
that
it's
is,
definitely
visualize it.
The research compendium model is like great, and then at some point you get a little complicated and it starts to become a burden.
And the file path or the file nested file system gets real nested at some point, you know?
Yep.
Okay, thank you.
I want to mention branching briefly. I didn't really know how to describe this, so I just took a quote directly from the manual. Sometimes a pipeline contains more targets than a user can comfortably type by hand. For projects with hundreds of targets, branching can make the code in targets that are shorter and more concise. So it lets you break repetitive tasks into separate targets, and it kind of happens automatically. So for example, fitting a model to bootstraps of data was an example that I came up with. So I'll actually just copy this and then find the first demo that we did here, because there's something called data in this already. And I'll show you what this is doing. So here, this target is creating a bunch of bootstrapped samples of our target that's called data using the sample frac function and the map function in R. So this is just the R code. So instead of writing a custom function, I just included it like raw there in tar_target. And the only thing I'm doing differently with this is saying iteration equals list, and I'm telling it to save the output as a list. And then here, I'm using this pattern argument. And so I'm saying, do this code, the fit lm full, do it, but do it for every element of data_boot. So if we run this, oh, there's a trailing comma, and I didn't save it. Delete the trailing comma and save it. Try that again. It'll create all these branches like on the fly. 100 different targets are being run. And if I look at tar viz network though, it shows up as a square. So it doesn't make 100 circles, it makes a square to show that it's a pattern here. And if I go tar read lm boot, it'll spit out all of them as a list. Or I could look at just one of them by saying branches equals 2, you know, and then that's just the second element of that. So this is called dynamic branching. There's also a thing called static branching. I want you to know it exists and it's really powerful. And if you need to learn it, you can learn it. It's also relatively easy at most places to get a targets pipeline working with the HPC. So those tar make, cluster make, tar make future, when I showed them to you, it was using my local computer, multiple cores or multiple R sessions on my local computer, but it's not too bad to set that up usually to use an HPC and actually send those out as Slurm jobs on the HPC and have them communicate back to your local computer. Or you can use it on an HPC. It is, for some reason, very difficult to get this to be set up at University of Arizona in particular. If it's something you're interested in doing, I encourage you to contact the HPC folks and maybe CC me, because we've been working on it a little bit leading up to this workshop, but not really come up with something super satisfactory. The best solution right now is you can use RStudio on the HPC through something called Open On Demand. And when you create an Open On Demand session for RStudio, you can request however many cores you want. So you can have an RStudio session running in a web browser using, 20 cores of the HPC. And then you can use tar make, cluster make. Workers equals 20 if you want. Well, maybe not 20 because you need some cores to run RStudio. Maybe do 15. And that'll run 15 targets at a time using the HPC. And so that's a really powerful way to use this. I also want to point out the possibility for cloud storage. So by default, that _targets folder is on your computer. It's not something that's going to be shared with collaborators. It's not something you should sync to GitHub because it's got large non-diffable files that don't work well with GitHub. So this is kind of like what is going to happen with your workflow. This is your computer. You've got this _targets, your targets.r, your R folder. But all that's gone GitHub is the targets.r and the R folder, the functions and the script defining the pipeline. So your collaborator is not going to get your _targets. Now, most of the time that's fine because they can run the pipeline, right? And they should be able to reproduce your analysis just by running tar make. But what if one of those targets took a week to run and your collaborator just wants to get up to speed quickly and be able to contribute to this project? And this is a real situation that I've had. Well, Targets offers the option to store the targets folder in the cloud. And it can use either Amazon Web Services or Google Cloud to do this. And then that target store is never actually stored on your local computer. All that's stored there is just a connection to that cloud. And so that means that your collaborator doesn't have to start from scratch and compute that week-long running target or whatever again on their computer. That just gets pulled down from the cloud. And the added benefit of this is that the targets that are stored on the cloud are versioned. So if you roll back to a previous version of your workflow, it doesn't have to rerun that target. It just rolls back to the previous version of that target that's stored in the cloud. So this is a really cool possibility, one that I have not really done much of on my own, but something that would be cool to explore and see how we can get. This is what I was asking you, David, about earlier, if UITS offers S3 buckets that we can use at University of Arizona. I'm not sure. But
yeah, they do. Yeah.
So this is something that you could set up if you're interested in doing this. So the wrap up is basically, I wanted to think about, a little bit about when to use targets. I talked about this in the beginning. And, it's something you have to answer for yourself, but things to consider are sort of like the benefits. And I think the parallelization is a huge benefit of it. How many steps is your workflow going to have, and how many of those steps can be run all at the same time? You got to think about your collaborators. So this does add an extra layer of complexity that may make it difficult for collaborators, or they may be less likely to want to contribute to the project if it uses targets, something they're not familiar with. On the other hand, it does kind of modularize things, and you can say, hey, I've got this function called fit model. Can you make that do a better job? And then all they have to do is fix that function, right? Or make edits to that function. And of course, you want to think about your comfort and your experience using targets. You may not want to use targets for, a project that is, you might not want to, you might want to, your first targets project might want to start something simple. But as you get more experience with it, I think it's worth it even for easy projects, easy small projects. So these are just some links to real life examples of targets workflows in the wild. The first one is one that I did, and the others are not ones that I did. This one is some Bayesian analyses, and this is a nice template from Noam Ross that has like targets and a bunch of other stuff in it for reproducible analyses. And I just want to end with where to go for help. This is a link to the targets manual, which is very thorough. A link to a shorter sort of version that is just reference for all the functions in targets. And then the targets discussion board, where people there are actually very friendly, and you'll often get comments from the author of the targets package. So if you're having problems or not understanding how to run something, this is a really good place to ask. And then we've got our office hours or drop-in hours every Tuesday morning. And you can also just make an appointment with me on my calendar if you want to talk about this and get help with it. And you can also sign up for our mailing list. And that is it. So thank you guys for sticking around to the end, and hopefully this was useful for you. And I hope I see some targets projects sometime in the future and get to help debugging them and all that. So yeah, thanks for coming.
Thanks, Eric. This was great. I'm learning tons, to say the least. And yeah, I'm going to try to work through fitting 2 more targets into this refactoring exercise you had us do.
Yeah,
So,
try it out.
Get a little more practice.
Actually, if you look on GitHub, I didn't put a link to this, but if you find, I can put it in the chat maybe, because I actually have this repository on GitHub, and there's a branch that has like the answers, quote unquote. So you won't see that with the use this method, but let me see here. It's called targets refactor. Yeah, so I encourage you to check it out on your own, but if you want to look at the quote unquote answers, obviously there's multiple ways to do this, but they're in the a branch, the refactor branch there on that repo, so you can check it out.
All right, thank you.
Cool. Thanks.
Hey, Eric, I had questions along the lines of your last slide. I was wondering if there's, if you're aware, if there's any other like visual representations of the logic for targets, or if there's any videos that you have to share.
Wait, what do you mean visual representations of the logic? Like something like the tarviz network map, or?
Yeah, just like the process or the flow of how it works.
Yeah, I mean, I would look at I would start with the looking at the targets manual, because there is like a walkthrough section that will help kind of reiterate what it's doing. So
Okay.
there's that. There's a video that's like basically what I did for that first demo in the manual there, linked to in the manual, or on the other website I linked to for the package, that are good places to start in terms of the logic. And then there are a couple of good talks by the package author that maybe I'll try to find those and send them out in a follow-up email to all the participants.
Cool.
That are I think pretty nice. And then as far as the like graphical representation, like the tar viz network map that we saw, one of the in the wild, or at least maybe a couple of the in the wild GitHub repositories that use targets have a setup such that the README for the repo is part of the targets pipeline and includes code to generate that dependency graph in the README, which is super snazzy. So that you can look at the README and you can see the whole logic of the project right there in the project README. And that's all generated automatically when you run tar make.
Cool.
I had a question about that actually. Is like when you do this, Eric, do you have like a priori sense of what that network is going to look like? Or if you're exploring things and you give up things, do you like take them out of the targets and just set them to the side so that it doesn't get too clustered with everything you ever tried before you settled on the answer?
So yeah, I've seen I've seen a few people who have been using targets long before me talk about sketching out targets. And so you can kind of write like dummy targets, right? Like we did in the example with the sys.sleep. Functions that do nothing, but we just give them names and we could make them depend on each other even, so that we could draw that graph and then fill in the code for the functions later. I've never done that, but it sounds like probably a really good idea. But I don't usually do it that way. I usually work more iteratively, and I write a target, load it, write some R code to do something with that target, turn that R code into a function, write another target that uses that function, and so on, and repeat. That's my personal way of doing it. And a lot of times what I'll do is I'll have like a folder that's called like notes or something that's like basically a scratch pad of just regular R code, not functions, but like regular analysis R code that I'll be working on. And then like once I've got a piece that feels like a target, I'll turn it into a target.
Okay, I guess I was kind of envisioning like that parallel one where you have like maybe there's 3 different kinds of models you're trying, but ultimately you're going to only publish one of them. Would you like, but to see
you could
it
also,
and to run it like that, you would have to make them all functions and targets.
Yeah. You can also like do that where you've got this exploration going on and you can just comment out targets. Like you say, okay, I don't want to run this anymore for right now. So you just comment it out in the list, right? And it's like there, the function's still there if you want to return to it later. And then maybe when you go to publish it, you're like, oh yeah, I never need that R code, just delete it. And like you delete the stuff you're not going to use. But
gotcha.
Yeah, you can totally comment out individual targets if you don't want to rerun them every time because you're not.
Well, you don't want your Viz network to be like this huge cluster of.
Yeah, you don't want that Viz network to be like really hard to read, and you don't want it to take forever. And when you're just trying to like debug one thing, like yeah.
Okay. Well, thank you so much. I learned a ton. I'm on board. I want to do this. I need to start small though, because
awesome.
It's kind of overhead.
I'm really interested to, if you get into using the JAGS targets, I'm really interested to hear what you think, because I don't know enough about Bayesian analyses to really be able to say whether it's like how cool it is on a scale of like 0 to super cool. So
okay.
I'd be interested to hear.
I'll be interested to start that. Okay.
All right. Well, thanks everyone for coming. I'll let you go now and have a great rest of your day. And please, let me know if you have questions or need help with anything.